Okay, right on the nth term of the sequence. Now we've got this sequence here, 5, 8, 13, 20, 29, right? And we want the nth term. Now, look at what the sequence is going up, right? And now here, the sequence is increasing by 3, isn't it? It's going up by 3. Now, is it the same here? No, it's not. It's 5, then it's 7, then it's 9, okay? So, when we've got the gap changing, right, it's probably going to be a quadratic sequence. And if you remember what we sometimes do to check, we do like the second difference, don't we? You can see the second difference is 2, okay? Now when you see the second difference is 2, then we're going to use n squared, right? So let's think about n squared, right? Because as I said, when this happens, this situation happens here, it's going to involve an n squared. Now, n squared are the square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Then we write down our sequence, right? The sequence that was given, 5, 8, 13, 20, 29. And all you've got to do then is compare, right? Let's see what we've got to do to n squared here to get to our sequence. Well, from 1 to 5, we've got to add on 4, haven't we? Yeah? From 4 to 8, we've got to add on 4. From 9 to get to the sequence of 13, we've got to add on 4. We can just keep on adding 4, don't we? So if you think about it, my nth term is going to be n squared, add 4. That's my nth term. Because I've got my square numbers, and all I've got to do to my square numbers is add 4 onto them, and I get the sequence. Now, part B, it says here the diagram shows tile patterns, okay? Find an expression for the number of tiles in pattern n. Now, there's a few ways you can go about this, right? First thing I would do is look at it in terms of the picture, right? Can you see here in the patterns, there are squares here, okay? And I'm not talking about the little squares, there's actually bigger squares taking place here. If you notice here, you've got this sort of square here in pattern 2. Pattern 1 is not so obvious, but in pattern 2, can you see here, this is like 2 squares, isn't it? Okay, because you've got 2 by 2 squares. That's like 2 squared. That's how many little squares are in there. Okay, this then would be a 3 squared, wouldn't it? This square here. Okay, right, 3 squared, which is 9. This here, you could see. Can you see that big square there? It's 4 squared, isn't it? Okay, 4 squared. Got to put it in there. Okay, and you know, even in pattern 1, we'd have like 1 squared. Okay, so it relates to the pattern number, doesn't it? If it's pattern 1 is 1 squared, pattern 2 is 2 squared, pattern 3 is 3 squared, pattern 4 is 4 squared. But we're not quite there, are we? You know, I mean, you could see here that we literally square the pattern number. Okay, so if it was like pattern n, somewhere down the line where n represents a number, we'd do an n squared, wouldn't we? So really, our answer then is going to be n squared. But it's not quite n squared, isn't it? Because there's a little bit more. Notice there's another little square being adding on each time. So this is like 3 squared plus another 1, isn't it? This is like 4 squared plus 1. It's like 2 squared plus 1. 1 squared plus 1. So really, it's going to be n squared plus 1. That's how you go about that by looking at the pictures here. The other way you could do it is, you know, you don't necessarily need to see these squares. You could write down how many little squares there are for each pattern. So you've got 2 squares here, okay? You've got 5 squares there. You've got 10 squares there, and you've got 17 squares there. And then you notice the gap changes, and then when you write your square numbers underneath this, you can see, look, your square numbers, n squared, what you've got to do to them to get this, you add 1 on. Okay, so there's 2 ways of doing this here, okay? 2 ways of doing this. Now, what I want you to notice here, right, we can be sort of clever about this, right? I want you to notice squares here, big squares, notice here, okay, we've got a big square, okay? Right? But is it 2 squared? No, it's not, isn't it? It's 3 squared. What's this here? Is this 3 squared? With this big square? No, it's not. It's 4 squared, isn't it? And here, can you see here? 2 squared, isn't it? And of course then, as well as it being 2 squared, you've got to add on 2, haven't you? And here, you've got to add on 2. Here, you've got to add on 2. Okay? Now, in terms of our formula, are we going to write n squared plus 2? Well, actually, no, because that's not true, isn't it? Because if it's pattern 1, it's not 1 squared. If it's pattern 2, it's not 2 squared. Pattern 3, it's not 3 squared. So if it's pattern n, it's not going to be n squared. Think about what we do to the pattern number. We add on 1, don't we? Yeah? So if it's pattern 1, we end up adding 1 to it and doing 2 squared. If it's pattern 2, we actually do 3 squared. If it's pattern 3, it'd be 4 squared. If it's pattern n, you add 1 to it, so it'd be n plus 1 all squared. Okay? So that's what's going on there. Of course, then you've got to add on the 2 then. So you've got that there. Alright? Now, there is an alternative way of doing this. Right? Again, you could just check all the numbers here. So there's 5, no, there's 6 in the little squares there. There are 11 squares there, and there are 18 squares there. Okay. Now if you write your square numbers down, okay, your n squared, this would be 1, 4, 9, and then think about what we got to do here to get to my sequence. Okay. Well, you've got to add on 5, haven't you, in this case? In this case, you've got to add on 7. In this case, you've got to add on 9. Okay. So it's n squared, and then you've got to keep on adding these. But this, what you're adding on here, is in itself an nth term, isn't it? 5, 7, 9. And this is a nice linear nth term where the gap is 2. So the gap is 2, so we'd write 2n. Okay? And then, of course, the term before it, if you've got 5 there, the term before it would be 3. So this here represents 2n plus 3. Plus then, so you start off with your n squared sequence, plus this will give you your sequence. N squared plus 2n plus 3. Okay? So that's your nth term. And this here is actually exactly the same as this. This obviously expanded. So something to think about. I would try and go with a picture pattern if you can see it, but if not, go with this sort of approach here.